on to my colleagues that will be presenting.
Hi, my name is Noah Lache. I've been with AXYZ for a number of years in a number of roles, similar to Kevin's. I've worked in service and engineering. Right now, my current role is in applications as the manager. In this department, we work with customers to help them develop the correct process for running different materials. A lot of those different processes we'll be showing you today as we present the new Trident machine. I'll pass over to the next person in the presentation.
Hi everybody, my name is Eric Hordyke. I'm one of the application specialists here at AXYZ Automation Group. Some of my day-to-day tasks include cutting samples for customers, helping develop new products, as well as working trade shows. Now I'll pass it back over to Kevin. Thank you.
Awesome. Okie dokie. As a quick rundown of today's agenda, we will begin our live webinar by talking a little bit about the new Trident. We will then proceed with a demonstration of our new machine, cutting a variety of different materials. During the presentation, feel free to ask questions. You may use the chat box at the bottom of the software application or send us an email to openhouse@axyz.com. At the end of the presentation, we will answer the questions. We will do our best to answer as many as possible. If any question is left unanswered, we will send out an email to you. Again, thank you for your time, and let's get this product demo started. I would like to briefly touch on AXYZ Automation as a company. AXYZ Automation Group is a global leader in tailored cutting solutions. This means our products are highly configurable to ensure we fit your application, materials, and needs. AXYZ Automation Group represents 3 brands, AXYZ CNC Routers and Knife Systems, WarJet, our water jet manufacturing division, and CNC Shop, the aftermarket entity. Our routers and knife systems are manufactured in Toronto, Ontario. Our water jet cutting solutions are manufactured in Talmadge, Ohio. Within our product scope, we manufacture CNC router, knife, saw, and water jet cutting solutions. Now, with introductions set aside, we will proceed to present you with the all-new Trident. And the new Trident builds off the success of the previous Trident machine. And to recap, the success of the Trident machine is based on the key distinctive attributes that allow it to stand out in the market. Trident has since the beginning stood for its industrial cutting compact footprint and the widest range of material processing capabilities. Application-wise, we've seen so many different customers from various industries use the Trident to meet their current demands and allow them for future growth. Noel will talk further on the applications we've seen.
Thanks, Kevin. Because of the versatility of this particular configuration, customers are able to cut a variety of materials. As you can see on the slide that's up on the screen right now, it goes from wood to aluminum, foam, print-to-cut applications, and ACM. We're also showing an incubator box that we processed and set up the job that we just try to help customers who are working on different aspects of the pandemic right now in terms of how they can process different kinds of acrylic to make different types of guarding. So because of that versatility, customers can now process anything that they would need to on this machine because we have a spindle as well as multiple cutting heads.
Looking back at Trident evolution, Trident has been a very successful product within our product lines. It's compact triple head with the spindle knife configuration, allows you to process multiple materials. It's got 6-inch gantry clearance, width from 5 feet to 7 feet, and length up to 50 feet long if you need it. The new Trident does introduce a new set of automation features, such as the knife calibrator tool, which we will demonstrate to you, the knife tool changer device, and because we have made some significant changes to the overall structure of the machine, it is 10% faster than, as a comparison from a point-to-point standpoint. Working off the success of existing tool changers, like seen on the video right now, which is the spindle tool changer, We have added a new tool changer that will work with tangential knife devices, which we'll see as a comparison. So mostly everybody's familiar with a spindle tool changer, and now we've introduced a tangential knife device. The tangential knife tool changer is a powerful addition to the Trident, which will directly improve workflow for users that process things like corrugated cardboard, cardstock, foam core, or rubber, or even gaskets. The tangential knife tool changer. It really introduces automation. The enhancements made to this feature, or the introduction of this feature, allows for the storage of up to 4 tangential devices. What this means is cycle times are reduced, and it's easier to program for your operators. Compatibility-wise, the device is compatible with the standard pizza wheel, box cutter, V-cuts, and creasing wheel devices. So we're very happy to introduce this feature, as it affects or directly improves the workflow of our customers. Similarly, working off the success of the existing Trident's tooltip sensor for the spindles, we have introduced a new method of automatically calculating the length of knife blades. As you can see here, the new laser-based sensor will calculate the length of your oscillating or tangential knife tools. It will also determine the angle of the blade and automatically apply a correction, which is what it's doing right now. This is manually done today, and the benefits are seen instantly with just speed. This new method of qualifying the tool is 2 times faster than doing it manually. This hands-free process will also prolong the life of your consumables, and the accuracy of the angle correction is within 1 degree, whereas manually an operator can be up to 4 degrees or greater. One of the other introductions for the new Trident is the addition of the electrical oscillating knife. Now this is a big deal, as it does provide you an expansion to the different materials you can process. Things like 13 millimeter or half-inch rubber can now be processed in 1 pass versus 2. And common materials like half-inch foam core can be cut at 550 inches per minute versus 300 inches per minute. So we're very happy to add that to the product line. And now back to you, Noel.
Thanks, Kevin. So basically during this process and this demo, we'll be cutting a variety of materials, from plywood, extruded, acrylic, high-density polyurethane foam, acoustic board, and print-to-cut on foam board. Just to show you the versatility of the machine and what it can do on a day-to-day basis. Most of the files, if not all the files we run, we basically set them up and create them using Vectrix. The system is also fully compatible with Onyx and Caldera, basically the standard industry print-to-cut and rip software. In terms of the material that we'll be processing, we want to thank Coastal Enterprises for the foam board, Acrylite for the acrylic, and Encore for the foam products. We've worked with these material manufacturers over the years, again, to develop a very clear understanding of how these materials work, so that when customers call us or they look to purchase one of our products, we're able to provide them with a very clean understanding of how to process the material, what tools they would use, the feeds and speeds. So from the time the machine goes into the building till the time they start producing product, they have a full understanding of how it works, and they're right into production, producing the parts they need.
Thank you, Noel. So I will be covering our viewpoints today, and that is through our live screen. And today we will first off show you what P1 full looks like, and this is a full image of the new machine. When we start to present the samples, we will switch over to the front tripod, which you can see there. Our foam number 2 sample is displayed there. And that gives us a good a viewpoint to not only the spindle, the knife cutting, but also the edge quality from the sample. During tool changes with the spindle, we will switch over to our ATC tripod, and you'll see the speed of the tool changer there. And there's also a few other angles that we will be working with as well. You might see me actually point over and do a shot like that. So just to orientate everybody and make sure that as we're presenting this, you kind of understand where things are going. And I'll pass it back to Noel, who will be describing the machine.
Thank you, Kevin. This standard system is very, again, as you said, versatile. Right here we have a carousel for the ATC, for the spindle. We hold 10 tools in this particular carousel. We do have different sizes depending on your application. The base of this table is a heavy-duty frame, which gives you, again, provides you with a very rigid platform to work from, so that when you're processing materials, especially things like acrylic, you will get a nice, clean edge in terms of the cut quality. One move on now to look at the head configuration of this machine. Okay. If you look closely at the head, first thing I want to look at, before we look at the physical cutting heads, I want to take a look at the new line rack for the tangential knife. This line rack, again, allows you to have 4 particular cutting tools, so it works with the tangential knife. Next to that will be the oscillating knife, or the new electric oscillating knife. We also have a camera which allows you to do AVS, and a couple of the unique things that we have developed for doing multi-side job processing, and a quick chain spindle that will work with the ATC. Again, because I have 3 different cutting heads, I now have the ability to run and process a variety of materials, from aluminum to high-pressure laminate to acrylics to foam boards, without having to basically change or spend a lot of time changing tools and going from, from one knife to the next or to the spindle. All my tools will either be loaded up in the carousel for the ATC for the spindle, or they will be loaded up into the line rack for the tang knife. Okay, back to you, Mr. Vecinos.
Awesome, thanks, Noel. Okay, so we will now proceed to run through the different materials, and we will switch over to our front tripod as it will give us the best angle to see. The first material on the board or on the machine is plywood, and this is 3/4 inch plywood. I'll let Noel speak further to the speeds and feeds and tooling that we're using for this particular material, and I will.
Thanks, Kevin. Again, we're going to run some plywood, some 3/4 inch thick. We'll be cutting at about 600 inches a minute. Again, one pass with a slight cleanup. One of the things we're looking for when cutting plywood is edge quality. So we determined to get the best edge quality when cutting this material is to use a compression tool. What that compression tool allows you to do, it gives you a nice, clean, crisp edge top and bottom, so that when the part is finished, you don't have to do any secondary sanding. You can take the part right off the table to making cabinetry and go right to your edge bander to build your boxes. Okay, so Eric's running that job right now. Once it's finished, we'll take a look, at the quality of the product that we have produced. Again, back to the whole versatility of the Trident. Right now, I am running plywood, 3/4 inch. And my tool right now is doing all my cutting out my holes. Once that is finished, it will do a tool change if needed be and pick up the secondary tool for doing the profiling, depending on the application. So sometimes you may have 1 tool or 2 tools in a job. But again, now that the machine is up and running, we don't have to have a lot of operator intervention. One of the things we also look at when we're running any of the jobs on the machine that will affect cycle time, will affect the way the machine processes, is dust collection. We pay a great deal of attention in terms of how we set machines up or how they are configured so that the quality of the cut, we know it will be affected by the dust collection system. And it will also affect the cycle time. So I think the job is finished now. So again, the job's all finished. Just waiting for the vacuum to turn off. That's how good the vacuum is. We have a very good high pressure vacuum system. It holds the material down so it's unable to move when cutting. Again, you can see now the part's been cut. It's all finished. Nice, clean, crisp edge, top and bottom. If I need to do any edge banding. In terms of the quality of the cut, it's good. But also look at the surface of the table. It's nice and clean. I can quickly remove this material and jump to my next process. Okay. Also, one thing you'll see on our machines is that we have alignment pins, which allows the operator to quickly and easily go from material A to material B or from sheet to sheet without having to determine, should I place my material here or should I place it in this location? He can quickly slide the material off he's just finished running and go to his next sheet of material, and quickly and easily, with the alignment pins, I'm in place and I'm ready to go. Now we're going to basically run that acrylic job. So again, we went from cutting 3/4 inch plywood. We're going to transition without doing anything except calling up the right job into cutting acrylic. So Eric's setting up to cut that job right now. Now, when we process acrylic, one of the things we're looking for is edge quality. So we spend, again, a lot of hours in application determining what the best process would be to generate edge quality. And one of the first things I will mention, and I'll probably mention it multiple times during this presentation, is dust collection. When cutting things like acrylic, if I don't get the right dust collection during the process, I will basically generate heat in my cut, which will affect my edge quality because I can get rewelding of the chips that are sitting in the cut when I'm processing the material. We will do a 2-pass cut on this job. The first part is a roughing cut. The second pass is a finish cut. The roughing cut allows the tool to basically load itself up, remove most of the material. The finish cut, almost like a polishing cut, will give you a nice, clean, polished edge. Once this sample is finished, we'll put it in the light bar so you can see what kind of edge quality we can generate right off the table. Right now, we're going to run a roughing cut at about 75 inches a minute, a finish cut at about 40 inches a minute. Again, it's one of the things we've really put a lot of effort into in terms of determining what is the best process for this material. Typically, most customers will cut extruded, which is what we're running. It tends to be a little bit more challenging to cut than cast. Cast tends to be more expensive. But again, through different tests that we've run over time, we've determined the best tooling setup, the best machine configuration, proper feeds and speeds to generate the right edge quality for this sample. Okay. So right now we're doing the engrave. Right now, we just finished the engrave. We're switching over for the tool to do the primary cut. Okay. For this particular tool job, we're running an O-flute tool. And what we've found over time is that an O-flute aluminum bit actually works exceptionally well for getting the right edge quality that we're looking for, which seems to be counterintuitive. You'll think I will look for an O-flute tool that's designed for cutting acrylic. And it does work, but we found that that aluminum tool works exceptionally well. And we've set up multiple customers running production with that same particular tooling configuration and setup. Basically, we just finished the roughing cut. We're going to do a tool change, and we're going to move into the final part of the process.
Thank you, Noel. Okay, so
Yeah.
I'll add a few tips to that. So again, the biggest thing about the Trident is that processing a wide range of material really requires more than one cutting head, and having the spindle and two other knives allows our customers to actually be able to take on different materials, different projects, and use different tooling to work on any type of application that comes to the door. The current vacuum system or setup that we have right now on the table is a 6-zone setup, and currently the pump is actually sitting, I think it was about 140 feet away from the table. It's got it plumbed a little bit further away, and we actually use the one pump for our vacuum system here.
Okay. This is the panel that I've just cut. You can see how the edge is nice and clean and well lit. Right? And that's what I'm trying to produce. I'm trying to produce a nice quality edge right off the table without having to do very much, if any, secondary work. Okay. So now that we've finished cutting the acrylic, we're going to switch again. Simply unload the material we've just processed. And we'll go to the next sheet of material we need to run. I haven't interacted with the machine in terms of changing tools. All my tools are loaded in the carousel. Simply going to push my material to the front of the table, line it up with the alignment pins. Again, that's the beauty of the alignment pins. I just pop it in. My head is sitting just in the middle of the table. I haven't told it where to go. I haven't positioned it in any way. I just call up the job I need, and I run the job. The machine will automatically select the tools that are in the file based on the position that they hold in the carousel. So I'll get out of the way while Eric runs this job. Now this is a little bit of a 1-inch thick precision board. We'll be processing it at about 600 inches a minute in terms of the pocketing and the profile. We'll do an engrave on it first, then cut some pockets, and then, again, cut it out. Precision board is used for a variety of applications, from signage to tool blanks to prototyping, depending on the density. The density we're running right now is a 40 pound. It comes in as low as 10, 15 pounds, as high as 75 pounds, and sometimes some custom poundage. Again, depending on the application. The only difference that I would see in terms of cutting in terms of the densities, might be the way how my tool reacts in terms of feeds and speeds. I may have to adjust my feeds and speeds slightly because as something gets denser, it's a little bit harder to cut. And again, we've cut a variety of these materials, so we already understand the geometry of the tool that I need compared to the density and the feeds and speeds. The tool we're using right now is a V-bit for doing the engrave. When we get to the profiling aspect of it, we will start using an O-flute up spiral tool, again, to help evacuate those chips. Okay.
Thank you, Noel. All right, so one of the other things we wanted to really emphasize is the ability to process thicker materials. And that's given with the 6-inch gantry clearance. So things like packaging foam for Pelican cases and whatnot, where customers are looking to really machine or cut something out of one part or one solid sheet of material rather than build it up with multi-material layers. Really, the higher gantry clearance does allow you to process this a lot better, a lot quicker as well. The other things I wanted to mention as well is the dust collection, which Noel touched a little bit on, but the dust containment system you currently see. The dust containment system, which we call the 5Y foot, sits and is locked to a specific height on the machine. So I'll get it view here. And this works really well with materials that you have a multi-dimensional pocket depth where you don't want any collisions really with the dust boot itself.
Another aspect of the foot is by having it sit just above the material. If I'm cutting a material that I want to be absolutely sure I don't have any scratching on it, I can just set it to be, half a mil, a couple thou above. That way I will get maximum dust collection, but there is no pressure being applied to the material, so I have no chance of scratching the surface, depending on what that particular, maybe it's an acrylic or a reflective acrylic, and I want to be sure that I don't have any marks on the surface or a polished aluminum. So that's why I can now process my job, provide the guarding that I need, also get all the chip collection that I require without touching the material. So Eric just finished doing the pocketing. Now we're doing the profiling. So again, we're running this at 600 inches a minute. And again, I'll come back to my topic that I always speak a lot about, dust collection. And again, the reason it's important is that as I run jobs, I want to be able to jump from sheet to sheet or material to material. I don't want to have to spend time either ingesting all that dust that's being expelled during the cut process, or spending hours a day cleaning up my machine or cleaning up my shop. I can now simply walk up to my machine after the job is finished, pick up my material, unload the table. There's my finished piece. Again, nice clean edges, very minimal dust on the table. So I can now transition to my next job, my next sheet, my next application without having to spend minutes blowing the table off. At the end of the day, the operator spends hours cleaning up the shop and cleaning up the machine. I have a nice clean pod that's ready to go. I have a nice clean bed that's ready to take on the next material. So I'll help Eric set up the next job we were going to run.
Awesome. Thanks, Noel.
Which is the cutting mat.
Yep. So one of the key benefits here of the Trident machine itself is we looked at the triple head configuration, but it's actually the one biggest thing that really our customers love is the rigidity and the strength of the machine to power through different materials. Whether it was the plywood, the acrylic, aluminum, or the high-density urethane we saw in different thicknesses, really the machine comes with powerful servo motors and a helical planetary gearbox setup that at the end will allow you to cut a lot quicker, through tougher materials such as high-pressure laminates, where having a larger tool, whether that's a 3/8 or a 3/4 tool, requires you to have really a strong, rigid gantry construction and a rigid frame. One of the other key benefits I think we haven't touched on, which we will be about to, is the knife systems. So right now we're setting up a job to cut with both the oscillating knife, the electric oscillating knife, and the tangential knife device, and show you the tool changer at this point as well. But again, it's that versatility to cut different materials and be able to switch from a solid substrate to something soft like thin rubbers and whatnot.
Right, as Kevin said, this is again different application now. We went from cutting with the spindle, we're going to cut with the knife now. So because I need to use a different knife than that is loaded in the head right now, the tangential knife will go over to the carousel, unload the tool that's in the head currently, select the tool that it needs, before the job and then proceed to run the job. So by having your tools preloaded, having your tools pre-calibrated with the new sensor we have for the knife, it allows, again, the operator has loaded a job where he needs to run a knife job, calls up the 45-degree blade. The blade goes through and it processes the folds. Again, we want to fold the material up, so we want to remove anything that would eliminate the folding of it nice and cleanly. Once the 45-degree cuts have been completed, we will switch over to the oscillating knife, and that will generate the profile cut to release the part from the sheet.
And within the tangential knife device cartridge, we have up to 4 maximum devices that can be stored. You can see we're switching over to the oscillating knife now. But that includes the creasing wheel, the pizza wheel for your dry fabric materials, such as carbon fiber or any other fabrics. Your saber blade, your box cutter for corrugated cardboard, and your V-cutter for things like acoustic board. So one of the key things we wanted to talk a little bit about was the actual acoustic material, where we've seen it, and that's in a lot of office environments. We've seen acoustic material increase in popularity. It's very easy to cut, as both Noel and I we can talk through for many hours. And it's honestly something very artistic to use. So we've seen multi-material, multicolor patterns being created in office spaces such as Google. And that's one of the key points that we wanted to really emphasize is we're always working with new materials that are emerging, and you're kind of ready to really put together the right tools so the learning process, the learning curve doesn't get easier for customers.
Okay, so now that we've completed this project, we're going to go to the next material. We're going to cut some foam board. And the foam board will basically, we'll be using our AVS system, our camera system, to find the registration marks. So it's printed material. The knife, again, because of the way the Trident is configured, I can now cut foam board on it using the AVS. But if my substrate that I had printed on happened to be printable acrylic or plywood or aluminum, I can simply, by picking the right tool, process that material. We just happen to be using foam board for this particular job. So the camera went out and they found the registration marks to align the job on the sheet, on the bed. Once that has taken place, it will then go through and process the job. So Eric's working to set up the camera right now. He's going to look for the registration marks. And here we go. It's looking for the dot. So when we spoke earlier about software, Onyx and Caldera, again, two of the industry standards for doing print to cut, you can basically work within those packages, generate a file, send it out to the machine, and the machine will process it. So it's a nice, clean process. So it's found the dots, it's determined the alignment of the sheet on the bed, and now we're going to cut the parts out. So that particular job that we're running, if that had been printed on that 3/4-inch plywood, for example, instead of using the oscillating knife, the system would have selected the spindle. You'd have gotten the same results, except that the substrate is different, so I would need a different tool. Not just a different machine tool in terms of the spindle, but a different cutting head in terms of the type of router bit that I would use.
This particular material, we're cutting it at 500 inches a minute, and we're using a standard oscillating knife blade. I believe this is a 25 millimeter round point blade. And so both the electric knife and the previous pneumatic knife both work with same standard knife tools.
Again, nice clean cut in terms of the product of the use, right off the bed. No secondary work required. It's perfectly aligned And that took place because we first of all found the registration marks to determine where the sheet was located. Once we determined the location of the sheet, then the app that we use will generate the realignment of the job, so the machine will cut it in the correct location.
Awesome. Thank you, Noel. Back to our presentation. Okay, so going over what we just saw, really what makes the Trident very unique is its versatility. And that was what we saw was through the oscillating knife, tangential knife, and spindle combination. Whether it's solid aluminum, up to maybe 1 inch thick that you're processing of cast plate 6063, or high pressure laminate or aluminum composite. There's definitely a lot of materials that really Trident can work out of the box, different tools that we normally use for plastics, wood, and foam and soft goods. And talking a little bit about the applications that we see the Trident in, we've seen it in a lot of packaging. We do see it in some marine applications. There's some particular customers that are also using for aerospace, and growing, as you know, the current situation is the use for PPE PPE products. So today you've seen both Eric and Noel wear and suit of both face shields. The actual face shields were provided to us by a local customer of ours, and that's one of the things I wanted to also talk about is we have a LinkedIn group called Fabricators Fighting COVID-19, which really houses different ideas and different customers. So we started a LinkedIn group, this LinkedIn group, to help our customers share ideas, designs, and calls to action. We have nearly 700 members, and there are a lot of great ideas shared each day. So please join and share your ideas, your knowledge, or if you want to learn more as well. There's a lot of stuff being put on there. Okay, so now let's go back to the camera view, and we'll give it to Noel.
Excellent. So we've cut a variety of products. We cut plywood, we've cut acrylic, we've cut precision board, we've cut soundproofing material, we've cut foam board. But again, now what I'm showing you is more things that I can do with this machine. I can cut aluminum plate. I can do, again, use precision board to create signage. I can make a tooling pack for my drill. So it has to be shipped, so I make a tooling pack for it. I can cut 1.25 inch light block for doing signage. Again, because of the COVID situation, we can cut the incubator box. Because of the way this machine has been designed and configured, it allows us, again, immense flexibility in terms of material and applications that I can run on a day-to-day basis without having to spend hours trying to, reconfigure my machine, modify how it's going to work from going from, again, plywood to foam to acrylic to aluminum. By having the spindles and the knives and the 280Cs and the mister, I can simply go from sheet to sheet, material to material, application to application without having to, very little, if any, downtime between jobs. Okay, so thank you for taking the time today to spend with us. Please be safe out there, and I'll pass this back over to Kevin.
Thanks, all. Okie dokie. All right. So we took you through our new features on the new Trident machine, the tangential knife, tool changer, the knife sensor, the new electric knife, and of course the robot structure. What this all means is that we've added key sets of automation tools that will directly impact workflow. Again, the biggest thing with the Trident is its multi-material capabilities, processing capabilities. And that's reinforced with it's the rigidity of the machine, the reliability, the compact footprint, and of course the tool changer systems, alignment pins, and whatnot. Okay, now time to take up our questions. And the first question that I would like to go through is, all right, aluminum cutting. If you're cutting aluminum, do you need oil? Absolutely. So whenever you're cutting aluminum, we need to lubricate the tool, and 95% of the time, we need to ensure that because aluminum is very soft, that the tool gets lubricated in either through oil-based lubrication systems, alcohol-based, or through cold air gun. Okay, second question. ACM panel cutting, routing for folding. The Trident can cut ACM day in, day out, as my friend Noel would say, and that's actually quite an easy process. The tool changer itself would house the V-cutter. It would also house the profiling bit, and the spindle would go over, pick up the V-cutter, do the V-grooves, move over, and pick up the profiling tool. We also sell a aluminum cladding specific solution called Panel Builder for the ACM industry, and this is driven by software and a machine product. So if you have any questions, please feel free to go on our website or to reach out to us, and we can cover that up. What are the three heads on the machine? The three heads are a spindle router that uses a carbide bit. It can be a V-cutter, an O-flute, a two-flute tool. It's usually made out of carbide or stainless steel. It can also house drilling tools. The second device that you saw in the middle was an electric oscillating knife. This device oscillates up and down, and it's used for soft goods and semi-rigid materials like rubber. The tangential knife device that you saw in the first position on the right is a has multi-material capabilities. This device itself has the creasing wheel, so if any of you want to do packaging, then for corrugated cardboard you would need different size creasing tools, and the tangential knife device you can store 2 or 3 different size creasing wheels depending on the size of the crease that you want, if you're doing single corrugated, dual corrugated, or even triple corrugated. The box cutter device is really meant for straight line cuts. The V cutter that we saw in the presentation, it's really meant for things that we want to fold, like brochure stands or any shapes that we want to fold very nicely. And from there, we also have a saber blade. The saber blade can be used on thinner substrate materials, even some thin PVC can be used. Some thin gaskets as well, gasket materials. And for that question, when is it available? The machine is available now to ship out, and so that's a pretty easy one. Can I get a recording of this video? Yes, you may. Not a problem. We've been recording this session. We will be putting it together and sending it out to our viewers. Again, thank you for joining. Okay, and let's see, there's a lot of questions today. We have about 120 registrants. Let's see. So pricing. For pricing, if you're based in the U.S., the machine starts at around $97 or what I would say $100,000 US, and your salesperson will be able to answer specific configuration questions. but it does start from that point in US dollars, and similarly converted to Canadian, we have it at a lower price point, which this one I don't remember off the top of my head. Okay, one more question. Is there a wireless remote available? Nope, there is non-wireless remote available. For safety reasons and practicality, we want a solid machine connection to the machine and approved by safety regulations. And so this has a solid cable running to the controller. Okay, one of the questions was how many vacuum pumps were we running? We were actually just running the one pump. It's a 10 horsepower, it's a 9 horsepower vacuum pump at a distance of about 140 feet from the machine. Okay, and software questions. Okay, so when it comes to using the tool changer, whether it's the spindle or the knife tool changer, it's just a matter of programming similarly to what you would with the spindle tools for the tool changer knife or the tangential knife tool changer. So let's say you have tools 1, tools 2, tools 3, tools 4, and one's a creasing wheel, one's a box cutter, one's a 45, and one's a saber blade, for example. You would program your job to have tools 1, tools 2, tools 3. If those are the tools you need in your job, you send that file to the machine, and during the operation, the active tool would drop off and pick the right tool depending on what tool path you're processing. How do I align a new knife that is installed? When you install the knife blade and you tighten it all up, you run a function to use the new calibrator device. That function will, that feature will then move the machine over to the sensor. The knife will plunge down and actually start to find the length of the device, or the length of the blade, I mean. At that point, it'll stop and it'll turn on its, I think it's 60 to 65 or 70 degrees, and actually move back and forth, trying to figure out what's that angle correction. Once it applies the angle correction, you know that your blade is nice and straight. What is the size of the spindle motors? The current one you're seeing in the video is a 5 horsepower spindle, and this is an ISO 30 cone, which is pretty much standard. And the Trident itself can work its way up to a 15 horsepower if needed. The machine can be equipped with a 15 horsepower. It really just depends what your application is, and we've seldom seen 15 horsepower needed unless you're doing thick, very thick, like 1 inch or ½ inch cast plate aluminum, and you're cutting really, really quick. Okay. The size of the machine is a 60 by 120. Okay. The electric knife, is this an electric knife or a pneumatic knife, and how fast does it oscillate? So the pneumatic knife oscillates at about 7,000 oscillations per minute. The new electric knife oscillates at 12,000 oscillations per minute. One little feature there to also include is the stroke. The stroke on the pneumatic system is about 1.7 millimeters plus minus, so that is over 3 millimeters. And the electric knife, it's within 1.5. So it's a lot smaller, and there's a lot less stitching. So the quicker you go, the more stitching you would see. With a shorter stroke, and you get less stitching, and it's a lot smoother of a cut. You go more aggressive on your materials. Okay. How many different knives do you offer, and how is the quality of cut on small diameter hole in thick material? Say 1 inch closed cell rubber and a diameter of 1.1 inch. Okay, so one of the things that we do have through the aftermarket group is probably, I would say, around 30 different oscillating knife blades, from flat point to double-edged to round points of different size. There's also serrated blades. So in this case, it really just depends with which one of the blades you pick through. How does the edge finish compare for the acrylic to flame polish finish? And this is it's actually very similar. In most cases, when we've talked to plastic fabricators that do plastic fabrication 24/7, that's the basis of their operation. What we found is the results given by the machine with the roughing bit and the finishing bit was way more than they needed. And the thing with flame polishing is that either you're flame polishing after doing a lot more manual processes, which adds time, or in this case, if you get a really good edge from your machine at this process, which is an early process in production, you bring it to a buffer and you have the same result. So it's a matter of steps that are lost. In some cases, the customers have mentioned not needing to buff at all. So there's other options as well in terms of tooling. You can buy PCD tooling. The standard O-flutes that we're using today cost about $37, not about $43. And as compared to PCD tooling, which you can use, which is $1,000. Okay, so the PCD tooling does offer you a cleaner cut, but it does come at a cost, so it really just depends. It's compatible with the spindle, but it really just depends what kind of finish you're trying to achieve. What and why did you put the black material under the board that you cut the maple leaves out? The black felt material is a cutting mat, and it allows the knife blade to actually penetrate the cutting mat surface without breaking the tip of the knife. When we're using things like a round point knife blade, we really don't want to plunge the blade into a solid surface like the MDF, as we risk breaking the tip and, of course, dulling it out. So the cutting mat, or the felt mat, does allow you some room there to really cut into it just slightly. It might be like 0.5 millimeter into the mat, and that's enough to protect and prolong the life of the blade and be able to cut the foam core. So that's one of the reasons there. Is the machine using the A2MC controller? Yes. Yes, it is. And front-end software we use today is a combination of VCarve and Adobe Illustrator for the vector graphics. So we use SolidWorks for some of the shapes that we designed. Okay. All right. So we'll move on to the next few parts of the presentation. I am going to respond back to all the questions that I didn't address, but I think we've got a good amount so far. Okie dokie. So if at any point you want to contact us, you can visit us at www.axyz.com. You can also email us at openhouse@axyz.com. So this is a little screenshot of our website, and you can see our new Trident page up and live through either the main homepage banner or by browsing through our CNC routers section. Depending on where you are around the world, if you want to contact or get in contact with somebody at AXYZ, you can also go to axyz.com and click on locations. And based on locations, you can see which office is close to you. In the U.S., we have many offices. We also have dealer networks for Middle East, Africa, Asia Pacific, and South America. So depending on where you are, we might reach out to you. Social media. Again, I mentioned the Fabricators Fighting COVID group. please feel free to join that group and share your ideas, learn more about what everybody's doing to protect others in different environments, whether that's creating acrylic face shields or actually putting point of purchase, point of sale barriers to protect our front staff workers. And this is the end of the presentation. So thank you very much for joining today. I hope you stay safe and healthy. We will try to do more of these webinars given the current situation, and we might tailor it a little bit more to technical, so it's more of a learning experience for some, especially for existing customers. So your feedback is always appreciated. Please feel free to reach out to openhouse@axyz.com, like I mentioned. But anyhow, I thank you very much for joining us today. Again, this is our hashtag #CutoutCovid. Find us on LinkedIn, where we have our group, and I appreciate, again, all of you joining. Thank you very much. Take care.